going to talk about Python toolboxes because they're going to be really important, because in this class we're going to do, when we write geospatial logic, a lot of times we're going to be asked to do it in a Python toolbox. So we're going to quickly go over some geoprocessing terminology, using some geoprocessing functions really fast, just a quick review, and then we're going to go into building Python toolboxes. So what we have here is, well, first of all, what is geoprocessing? And geoprocessing is a framework and a set of tools for processing geographic data. It's a library and a collection that allows us to do all these geospatial operations that make our day-to-day job easier as GIS analysts and programmers. So geoprocessing tools perform operations on data sets, and these tools create resulting output data sets. So we have our imports, and it starts with import ArcPy, from ArcPy import env. And then we're going to take a variable, assign it to result, and we're going to do ArcPy dot the submodule that it's in this case analysis, and then buffer. And then there's a set of required parameters. In this case, for buffer, it has 3. We have our distance, our input, and our output. Here I'm inputting a shapefile, paving, and then I'm buffering this information, saving it to a Scratch GDB, and buffering it 100 meters. This returns what's called a result object, and a result object is this opaque object that allows you to get, that acts both like a list and a dictionary at the same time, or a class with the properties. And we can get the results of our variable by providing the index for our outputs. In this case, it's 0. So we have FC equals result, and then we can print out results if we wanted to. So like we said before, geoprocessing is a framework that allows us to work on geoprocessing data, but there's a whole bunch of factors that help us work with that data. And within the framework, there's this thing called environmental variables, and this is controlled under the env submodule. So we can import that by doing from ArcPy import env, and then start accessing properties. One property that's really helpful at times, especially when you have a lot of intermediate data and you don't want to have to manage it every time you run it, is env.overwriteOutput. When you set that to true, it tells the geoprocessing tools that they can go ahead and erase this information if it's there, so your output data. So if you look back at our previous slide, what we see here is that we have our output feature class, and we're writing it to our Scratch geodatabase with the same name. If buff 100 meters already existed within that workspace, it would throw an error, which is something we don't want. So it's really important to use our environmental variables to help us get our customization done right. So when we look at geoprocessing, especially in the guise of doing it from ArcGIS Pro, you'll notice some icons, and there's 3 of them. We have ones with this little hammer, and these are built-in tools, and these are internally built-in Esri tools. They're usually written in C or C++ or some other language. And then we have model tools, which are tools that are built using Model Builder, so we're chaining tools. We won't be using those in this course, but it's good to know that they exist. And then we have script tools, and these are tools that are run locally on disk, and they're either from a .py file or the .pyt. So there's some vocabulary that we need to know. So a toolbox is a place that stores our information, and then inside is a tool, and you get this tool dialog. And this is defined 2 ways. If you have a traditional TBX, which is the old style way of building toolboxes, you would go through a GUI process to define what you want, or it can be defined using code, which is what we're going to use with the .pyt. It takes those input parameters for, in the case of a .pyt file, the Python toolbox, and it creates some XML that defines how this GUI should look. And if you go and you look at it, you can see that if you have input and output features, and all these types are easily defined, and you can see where everything goes. Some additional vocabulary that's really important is our parameters, and these are our inputs and outputs. And if we go back to our OOP that we talked about before, and one of the goals is that we wanted to control the inputs and outputs of tools, and we can check that off by using parameters. These parameters allow us to do type checking and making sure that the input type is actually the type that we want it. Some other information that's really helpful in Pro is that it stores the geoprocessing history. So every time you run a tool, and whether you have a failure or a success, you can go back and you can go to that pane and you can look at it, and it brings back the historical information. And then sometimes you'll also hear throughout your day geoprocessing tools referred to as geoprocessing services, and this is just geoprocessing tools that are hosted on the World Wide Web. So it's a it was published out to ArcGIS server. So we can use geoprocessing tools, either our own or the built-in, to either build other tools or um, to run custom ones yourself. So GP tools can be run from code or from Pro. So Pro has that clickable interactive GUI, and here's an example of me going through and running some code, and I'd click run and it would go through and it would do the information and then populate it onto my map if I said so. But I can do the same thing also, and I could run that code locally, and I can say, here's my inputs and outputs. I want to buffer this information. I want to do it 150 feet, the planar method, so it's not geodesic because my data is in projection. I want to dissolve any overlapping buffers, and I can print out my output. Notice we don't get that rich visualization that we get with ArcMap Pro, so we don't see the initial results visually, but we know our data is there. So we can then, maybe this is a pre-processing step, so we really don't care what it looks like. But if you're a visual person, it'd probably be better to do this in the Pro environment than doing it inside of the command line right now. And then we could turn around and we can erase our data. And here you can see we get back that result object. I didn't use the bracket notation 0, and it says true. And if I wanted to actually have it print out true, I can put that bracket and rerun this. So we need to understand tool parameters to do it. There's two very important things, and I'm going to show you right now. One is to use the actual tools help, and the other one is there's a general tool reference. So I'm going to, for the buffer that I've been working with, you can see that there's a rich set of help for every geoprocessing tool in the ArcPy toolbox. I'm not going to go through and read everything, but for any tool that you want to use, there's an associated help with it. And that's good to know. And then for general ArcGIS Pro tool reference, we have a nice collection of information that helps you build tools. And we can go through and we can see that it's really rich and helpful. So these are going to be your best friends as you go through any course or life in general, because you might not know the exact name of something or how the inputs go just by the description of the variable name. So it's good to sometimes look and make sure things are right. So we hinted at this before when we were talking about the icons earlier in our lesson, whether one was a built-in function or a custom one or a model. And this is just going to reiterate that. So building our custom geoprocessing tools, mainly we're going to do it through Python toolboxes and geoprocessing models. Geoprocessing models is this drag and drop, very ArcGIS desktop. It's also in Pro. I should just fix that. Pro tools, and you don't need to really code, and we're not going to do this. And then we have your Python toolboxes, and these geoprocessing toolboxes are going to be created entirely in Python. They're going to have an extension .pyt, and they can really easily create them to create a new toolbox. The PYT structure, before I show you, I'm going to talk about it, is a collection of classes in a single file. There's a toolbox class that's going to hold all your tools, and then a tool class. And um, you can have one tool, which is the default, or you can have multiple. And it doesn't matter how many tools you have in there, as long as each class is registered with the toolbox, they'll show up within there. And we'll talk about that in a minute. Each tool can have 0 to n number of inputs and outputs. So you can have a tool that produces no inputs and no outputs, but you know what it should be doing. It's not really recommended because once it moves from your system, it probably won't work anymore, but you can do that. And then each tool is stored in a list, and that's how it's registered. So let's take a look first about how we're going to create a .pyt. And what I'm going to do is I'm going to go to ArcGIS Pro that I have, and I have a folder. And I'm just going to right click anywhere within that folder, do new, and then Python Toolbox. And it'll create a new toolbox. It brings up a metadata page where you can go ahead and you can update this information as needed, along with other information as well. Now we have our toolbox. How do we go ahead and edit it? Well, you can go ahead and right click on the file and hit edit, or you can use your favorite IDE in order to do this. So in this case, I'm going to use Visual Studio's Code. And here what I did is I just went in and I opened it up in Visual Studio's Code. In order to get this to work and to be recognized as a .py file or use the Python environment, I had to register it in my settings. Once I did that, you can see that we have the two classes. But I added some other lines of code. So instead of just having the ArcPy import, I added logging, sys, and OS. You'll also notice at the bottom of the page I did if underscore main underscore equals main. And if I go ahead and run this, it'll allow me to call my tool and it'll finish it. This means I can take the logic that I write, and before I keep going into ArcGIS Pro, I can instantiate that tool, pass in the information that I need for the parameters, and I can execute all that information. I'm just going to minimize that, and let's take a look at the toolbox. Here in the toolbox, this is where we define our tool. You can provide it a label, so I can call this first toolbox for Johns Hopkins University, and I can give it an alias as well. It has 3 public variables that are defined within the initializer. The first one is the label, the second is an alias, and then we have our tools. And our tools is a list of uninstantiated class methods that are going to be used to reference the tool within each one. So if I had a tool2 class, I would just do comma tool2 and put it in that list, and then until I get to tool n, and you can call it, it doesn't have to be tool, but it can be whatever you want to call it, and it can go right in there. Now let's take a look at the tool class. Once again, we have our label. The default is tool, but I'm going to call this amazing tool now. We can give it a description, and we can specify whether we want it to run in the background or not. The default is false. If I set it to true, it'll kind of disappear in the background and return the result back. Leaving it as false is quite okay. Now, in order to define our inputs, we define it under the get parameter info. And this is going to allow us to define our inputs and outputs. In this case, I'm going to define 2 parameters. The first one's an input, and I want it to be a feature class or some type of feature information, vector information. So I do param0 because it's my first parameter, arcpy.parameter, and there's some pieces of information that I need to provide. We have a display name, a name, which is like an internal name for the system. These have to be unique. Display names do not. The data type that it needs to be, whether this information is required or optional, and then the directions. So since the direction is an input, I only have two choices here. It can either be required or optional, but I want the first input to be required. Then I can go ahead and define my second parameter, so param1. We do arcpy.parameter again, provide the display name, a unique name for the variable, the output data type, in this case it's DE feature class, which is going to allow us to export a feature class to the user. We set the direction to output, and then it's derived. Derived means that you're going to come up with the name of where the information is being stored. We could set the output direction with output. We could also set it to required as well. And what that allows the user to do is that it allows them to specify either a path or a name or whatever other piece of information you want. But it requires them to say where I want this piece of, in this case, the feature class, where I want this feature class to be saved and what the name of it is. It's always good to default to derived unless you have a specific need where that user needs to put that information. There's other pieces of parameters that we can focus on here, and that's the isLicense, update parameter, and update message. The isLicense allows you to put custom licensing checks in there. So let's say your tool uses spatial analyst or geostatistical analyst or any of the other extensions. Here, this is where you would do your check to see if you can check out the license to perform that operation. With our update parameters and our update messages, these allow users to modify the parameters based on some internal validation. So whenever the parameter is changed, it's going to call this logic and go through there and make sure everything's okay. And we can have them fire off some messages, let's say they're after internal validation, it passes or fails, and report that back out to the user. And then finally we get to execute. And this is the part of our code where we take our inputs, perform our logic, and write it back out. So there we have it. That's a Python toolbox and the general structure. So let's get back to our presentation. So we saw this before, and I'm going to rehash that, and that's the parameters. So we define that within our parameter function, and we have two types, inputs and outputs. Parameters can be derived, required, or optional. And for each parameter class that we're going to define from ArcGIS parameters, there's 6 pieces of required information that you should always provide. Name, display name, direction, data type, parameter type, and enabled. Enabled will default to true, but you can use this one to state whether something can be accessed or not. So we're going to define that within our get parameters info. Here we see, once again, we have our input and outputs defined, and then we define it within that list, just like we did with our tools. So there's a lot of data types that Python toolboxes can support. In order to support them all, I suggest you look at this link right here. And we can see that each data type has a specific keyword associated with it. So let's say we need an address locator, you would do DE address locator. But then if you were working with aerial units, it would be GP aerial units, or Boolean is, instead of being Boolean, is GP Boolean. So there's a lot of, sometimes they're not intuitive on what the different parameter types should be. So use this chart and keep it in your back pocket anytime you're writing out logic. But what you'll find is some of the types you'll never use. So coverages you should never use in Pro really anymore. There's a couple other ones that are pretty much have gone to the wayside and aren't featured data types to store your information in. And they're really only there for historical purposes. So I mentioned this before, but I'm going to go talk a little more formally about that, and that's the type of parameters that you can have. And we have our required parameters, and this requires an input from the user. The tool will not execute if you don't supply those variables. Optionals doesn't require a value from user, and derived, which only applies to output directions. Doesn't show in the dialog box at all, but it allows you to return some piece of information. So that's the end of lesson 3. If you have any questions, please post it in the forum.